Good afternoon. My name's Yi Chao, CEO and founder of Seatrec. Thank you for the opportunity to present some of the technology we have been developing over the years to you today. I'm sorry I cannot be there in person to attend the meeting, but I do wish you all a very productive conference this week. Today, I'm going to introduce you a new product, autonomous profiling float powered by ocean thermal energy. Seatrec started from academic research and then development. I got my PhD in oceanography from Princeton University. I worked for NASA Jet Propulsion Lab for 25 years. With funding from the Office of Naval Research, I have developed a patented technology to harvest energy from the ocean temperature difference. In 2016, Seatrec was spun off from Caltech with exclusive license to commercialize this patented technology. We are fortunate to continue to receive funding from the US government, NOAA, Office of Naval Research, and then DARPA, as well as grant funding from family foundations, specifically Breakout Lab, Till Foundation, Schmidt Marine Technology Partners as part of the Schmidt Family Foundation. Recently, we have been receiving private investments as well as industry partnerships to develop some of the commercial product I'm going to talk about today. This is a very exciting time. This is the first year of the decade of the ocean. Climate tech and the blue economy are emerging. To address these exciting opportunities, we need data, a lot of data, to help us to make better decisions, to plan our operations. One of the biggest limitations working in the ocean is a lack of data. I can use the seafloor map as an example. The panel on the left-hand side show you the seafloor remain to be mapped. As you can see, most of this map of the seafloor are near the coastal areas of the developing nation, north of equator. Most of the open ocean and then south of equator remain to be mapped. Over 30,000 submerged seamount, as I plotted the black dots on the right-hand side, it remained to be charted. These were posed huge navigation hazard. So to map the 80% gap over 30,000 of the seamount will improve our understanding of the ocean and the impact of the climate to protect our resources, and then more importantly, to plan our operation offshore in the open ocean. One of the biggest challenge to map this huge amount of ocean is the high cost. Traditionally, sonar on the ships is used to map the seafloor in a single beam in the early days and multi-beam in the recent years. It estimated to require 300 ship years or almost $5 billion USD to map the 80% of the seafloor. In the last couple of decades, there has been a revolution of underwater robotic. Now more and more autonomous underwater vehicles or AUVs with sonars are being used to map the seafloor. These AUVs are powered by batteries. Sometimes they can last for hours and then even for a few days. Once the battery runs out, the expensive equipment AUV had to look for the nearby ships to charge batteries on board. So that's also posed a high cost of rely on ship operation. Seatrec has been developing the solution to generate energy in the ocean. Specifically, we are converting the relatively small temperature difference in the ocean into electricity. Over 2/3 of the global ocean have this temperature difference between the warm water at the surface and the cold water at depth. Using phase-changing materials, we can convert this relatively small temperature difference into electricity through a thermal expansion once the material goes through a phase transition from solid to the liquid. Essentially, we can put this material in the pressure housing as they stay in the cold water in the deep ocean, they remain at the solid state. As they come to the surface, the solid is melted into the liquid, and that's give you the thermal expansion, taking the thermal energy into a mechanical energy. And that mechanical energy can be used to generate hydraulic pressure, spin the motor, and then generate electricity and recharge the battery. It's patented in 2011, and we have been continuing to develop the technology throughout the years, starting from the prototype about 10 years ago. We have successfully tested and deployed in the ocean. What I've shown here is the first prototype as described as the first self-powered underwater robots by Popular Mechanics magazine, and collecting over 1,000 profiles during the 18-month mission of the coast of Hawaii. We have been continuing to refine this technology as a commercial product. Shown on the left-hand side is the solid to liquid SL 1,000-meter energy harvesting system that can be attached to a profiling float like an Argo float. There are 4,000 of these floats in the ocean today. With our energy harvesting system, this float can have longer life, can power additional sensors, and then more importantly, being sustainable using the clean, renewable energy to power these underwater sensors and vehicles. The product we are very excited to release next year is this single beam echo sounder float. Essentially, we're integrating 3 mature technologies: profiling float like Argo, energy harvesting using our SL technology, and the well-developed echo sounder with the single beam. So we can map the seafloor when the float is parked at 1,000 meters using relatively small device of the echo sounder and then low power as well. As the energy is consumed, we can have the charging operation to have a profiling float moving up and down in the upper 1,000 meters. When they come to the surface, they can send the data back. And then once they have enough energy, they can park at 1,000 meters to continue to collect the seafloor data almost indefinitely. The same technology we have been developing for underwater gliders. This is the illustration for a product to be released later part of the 2022, specifically for the Slocan gliders. Our SL powered glider can be used to extend the lifetime so that we can put the glider away from the coastal areas and then into the open and the deep ocean, have essentially unlimited endurance for glider operations offshore. The same technology, we also developed the concept to power seafloor sensors. In this particular case, is ocean bottom seismometer. Traditionally, OBS is deployed at the bottom of the ocean on the seafloor using primary batteries without real-time data transmission. Our concept is to attach our profiling float with a tether so we can continue to profiles in the upper ocean, provide unlimited energy for the OBS operation. And at the same time, we can provide the data to the satellites or the surface ships or surface device, and to extend the operation of OBS and then provide near real-time data transmission. Finally, another concept we are developing is to scale up an energy production. This is a new technology we patented in 2019, and then using phase change between liquid and gas. In this particular case, we can have a continuous operation to generate energy on the order of tens of watts continuously. So we can accumulate on the order of kilowatt hours and then to charge underwater vehicles, specifically the propeller vehicles like the AUV. The illustration on the right-hand side is showing 2 configurations. One configuration for underwater, we can install pipes through the thermocline, so we can pump the liquid from the deep or cold water to the surface. So the warm water at the surface vaporize the liquid. The vapor generate the big volume, spin the turbine, generate electricity. I also include a drawing for our Arctic application. In this case, we are harvesting energy from temperature difference from relatively warm water below the ice and the extremely cold air temperature on top of the ice. So both of these configuration can be accumulated as a power station, provide kilowatt hour or more energy for the AUV to get charged every day or every week once the battery is running out without the ship operation. So these are the few technologies we have been developing at Seatrec. We are very excited about this infinite source of thermal energy to power the ocean, provide the data, provide the deeper insight. I have my emails here and phone number. Feel free to contact me if you have further questions. Thank you very much and appreciate the opportunity to present Seatrec to you today.